Hello, and welcome to another segment of Geology 1 Processes and Products Lab DVD. My name is Renee Clary, and today we will be talking about metamorphic rocks. Before we discuss metamorphic rock types, though, we first have to talk about metamorphism. What is metamorphism? Well, it is the solid state transformation of pre-existing rock through heat, pressure, and or chemically active fluids. Well, that sounds complicated, doesn't it? Basically what it's saying is that it's a solid state change, meaning that if we add too much heat or pressure and end up melting the rock, we no longer have a metamorphic rock. We would have an igneous rock. Igneous rocks form from magma, or, if on the surface, from lava. Therefore, we can add heat and pressure and change the rock, but once we melt the rock, we no longer have a metamorphic rock. Now, there are various types of metamorphism. Contact metamorphism is what occurs when you have lava or magma coming into contact with pre-existing rock. Basically, the rock is baked. It's changed through heat and the fluids, magma or lava. Dynamic metamorphism, the main agent there is pressure. Dynamic metamorphism occurs along strike-slip faults where there is intense pressure but not so much heat generated. And finally, the most common or the biggest type of metamorphism is regional metamorphism, which is usually associated with subduction zones or convergent continental plate boundaries where there is intense heat and pressure, and we see metamorphism over a very large area. So, how do you classify metamorphic rocks if you're given some in a sample kit for your lab? Well, remember, we classify all rocks based on texture and composition. The good news is, with some metamorphic rocks, we see a special type of texture. It's known as foliation, but it's only exhibited by some of the metamorphic rocks. In foliation, because of heat and pressure, some of the parallel minerals will start lining up. These platy minerals like mica form parallel lines. And I do have a hand sample of a metamorphic rock to show you. There we go. Now, you can see that right through this area, we actually can run a line of minerals moving up. This rock has been subjected to heat and pressure, and that's why we see the minerals here lining up in a straight line. The platy minerals line up for metamorphism. This is known as foliated texture. Now, this diagram will show you the type of differential pressure that produces that foliation texture. Here we start out with a rock. We have pressure in all directions that is equal. Here's a good sample of a granite. Now, during metamorphism, we may have some pressure or stress up at the top. We may have stress at the sides, but look at the increased stress in this direction and look at the resulting alignment of the platy minerals. I have some close-up views of that. This diagram shows us the platy minerals before metamorphism, and again with stress, differential stress in one plane, we see the alignment of the platy minerals. If we look at the texture under a microscope, this is what we would see before metamorphism and after. Let's do that again. Before metamorphism and after differential pressure, the platy minerals do line up, these nice bands. Now, we can actually take thin sections and look at foliated texture under a microscope using polarized light, and you can see how that foliation is very visible. Look how the minerals line up. I have one more example of that with a muscovite schist, And here you see the mica, the muscovite, lining up in parallel fashion. We have varying degrees of metamorphic textures as well. With increasing metamorphism, we see more and more obvious foliation. We can start off with a very fine foliation with slate. We get flat foliation. Increase the grade of metamorphism and we get a type of rock known as phyllite. It has a wavy, wrinkled texture, wavy, wrinkled foliation. We still can't really see the foliation as far as minerals lining up with phyllite and slate. However, when we get to schist, we've increased our metamorphism, our metamorphic grade, and we see a scaly foliation, very visible alignment at this point. The greatest degree of metamorphism would be gneiss. This is a banded foliation, and this is what you would have when you see those alternating light and dark layers. Here's a diagram that will show you the slate, flat foliation. It splits very well and is used for building materials, especially roofs. Here we have phyllite. Phyllite usually is very wavy. It feels very wavy and looks kind of like a gunmetal gray, very common color for phyllite. Schist, we can see the minerals lining up, but it's not so obvious as in this example. Here we have a banded rock where we have light and dark layers that are alternating. And I do have some samples to show you of the varying degrees of foliation. The first, we're going to start with a lower level of foliation, or slaty textures, where it's a flat foliation. And you can see slaty cleavage there. And this one as well. This is also another example of slate. If we increase the grade of foliation, we end up with something known as phyllite. And phyllite can be very wavy. You can kind of see the wave there in the phyllite. Wavy, wrinkled foliation. Here's another example of phyllite. Okay, then we can move to a schist. This one's nice and shiny. Oh, this one sparkles a lot, has a lot of mica in it, but you can see, if I can hold this in place, you can see the lines of foliation of this mineral, of the minerals lining up. This is a schist. Another example of a schist, not so shiny, is this guy. You can see the micas. And we do have foliation that's visible with the naked eye. Of course, the most obvious type of foliation would be a gneissic texture. And I have some samples of that as well. This one's a great example. Look at the banded texture there. We have the black and white minerals that are alternating. Here's another example. And we can see the lighter minerals. We don't have as many of the lighter minerals, but you can see the banding here running through the rock. And this is a type of gneiss in which we have larger layering. This is called augen gneiss, augen for eye. There are eyes within the rock, but this is a type of gneiss as well. So those are the degrees of foliation. We start out with a lower level of metamorphism, and we have the slate. We increase metamorphism, phyllite. Increase it still, we get a schist, and now we're starting to see the visible foliation with the eye, with the naked eye. And finally we have gneiss, banded foliation. Okay, but not everything is simple in nature, right? What happens if you don't have a foliated texture in a metamorphic rock? You can also have a crystalline texture, and there are various types of crystalline textures in metamorphic rocks. And even if you have a problem identifying a crystalline texture, remember that all rocks are classified according to texture and composition. So when we're classifying according to composition, we look at the original rock before it was metamorphosed. An equigranular crystalline rock, I have an example here, would be marble. Crystal sizes are equal, and this is metamorphosed limestone. Remember, limestone is made of the mineral calcite, so if we put acid on it, it should fizz, right? And there we go. Marble, of course, is used as a building material, so we can see many slabs of marble that are available for countertops, tiles. But again, if it's marble, if it's metamorphosed limestone, it should fizz. And I'm going to hold it up like this. Let's add some acid right along the corner. Oops. There we go. Fizz. Okay. Metamorphosed limestone, equigranular texture, would be exemplified by marble. Okay, we can have other crystalline textures as well. A microcrystalline fine grain rock is a hornfels, and I do have a sample of hornfels to show you. You can maybe pick out some of the little crystals here. There we go. No foliation, but very fine crystals. Hornfels. And we also can have a sandy texture. When quartz is subjected to metamorphism, we end up with a rock known as quartzite. And I do have another specimen, rock sample, of quartzite. There we go. It has a sandy texture. And our final texture of metamorphic rocks would be a glassy texture. And an example of this would be anthracite coal. I don't have a hand sample to show you, but I do have a photograph. And you can see that the fracture here looks like broken glass, very similar to quartz. This would be coal that is put under a lot of heat and pressure and metamorphosed into a new grade of coal known as anthracite coal. So, you received a bag of metamorphic rocks and you have to identify them. Where do you start? The first thing you would do is look at the texture. See if you can identify any foliation and look at the degree of foliation. Do you have slaty cleavage? Do you have phylitic cleavage? Schist? Do you have a gneiss? If you don't have foliation, look at the crystals. Do you have an equigranular texture, a microcrystalline rock? You can identify that way. Also, you want to look at the composition. For example, even if you can't pick out the crystals in a marble sample, if you drop acid on the metamorphic rock and it fizzes, you know that it's metamorphosed limestone. Well, that concludes our segment today on metamorphic rocks. As always, if you have any questions about this or anything else, please feel free to email your instructor. He or she will be happy to answer your questions. Thank you very much for joining me today. Have a good day.